Hello guys, so let's get started with blocks. So what is a block now? If you remember from before, from our blockchain warehouse example, we were talking about a box somewhere in the warehouse, and nothing inside yet, just a box. And this box we said is a block in blockchain. So now let's talk about the block. How is the block actually structured? So this will get a little bit technically, so forgive me about that, but that's some basic knowledge that you need to know. It's not that much. Okay. So this block structure itself, we made this table where you can see, for example, it starts with a block size. So how big is this block or this box if you imagine it from warehouse? How big is it? How much is contained inside? That's the block size, 4 bytes long. And then we have this 80 bytes block header. What is the block header now in this warehouse example? Block header, you can think of the label on the box. So on the box we have a label. And that's really important because it's somehow unique for it for every block, and it's really important to have it. And this is 80 bytes long. Then we have 1 to 9 bytes depending on how much transactions we had, how much articles went inside the box. We have this transaction counter, so the amount of transactions that are inside. And afterwards, variable length transactions. So all the transactions are at the end. Now to the block header, so to the label itself on the box. What is the block header actually? The block header contains of a version. This is 4 bytes long, that's the starting thing. It's the version of the protocol. So if somehow in later Bitcoin protocols, if the block header is changed, the structure or something is added and so on, we also have to change the version. So this is more for developers. It's important to have this version field inside. Then we have 32 bytes previous block hash. This hashing and so on we will talk later on, but we said in the blockchain warehouse example that's the weight. So if you remember from that, so this is the weight of the previous block, so if of the previous box. That's important here, actually the header of it. So this is the important thing here. It's a reference. Then we have 32 bytes of Merkle root. That's actually all the transactions somehow put together from the example that we were talking about in blockchain warehouse. That's the strategy of this blockchain manager. So this will get in here as a Merkle root, everything back together, all transactions and Merkle root, a hash. And afterwards 4 bytes timestamp. So when happened this block, when was the block created? 4 bytes of difficulty target. That's also something that we are going to talk later on with mining, when we talk about how mining works. That's some value that a miner is trying to find to show it has proof of work. So something that the miner is searching for. And 4 bytes nonce, that's actually what the miner found. So that's what he's trying to find out. The first one who finds it will get the reward. That's all added in the block header. And now that we know that, how is a block now identified by other blocks? So because we didn't have anything like this in the block header or in the block itself, that's actually done. It's not included in the block. That's done. We are calculating a hash from the block header with SHA-256, this twice. So that's some hashing algorithm. We will talk about this later, but that's how we identify it. So that's not included in the block itself, but you have to use this algorithm to find out the unique identifier of the block. We could, for example, also think about the block height. So whereas it in the position in the blockchain, but that's not really unique because we have some cases, what we are also going to talk later, where we have multiple blocks at the same height, for example. That's possible, and then this is not unique actually. and each node has to store it separately if they need it, so this block identifier. Now the one special block, there's a Genesis block, so it's called Genesis block. That was the first block that was created. Actually, it was created by Satoshi himself. So a special block, it's hard-coded into the clients most of the time, or it is all the time hard-coded there. And we have this, it was created 2009, 1st January, so 3rd of January, and it contains a hidden message. So if you want to look up for it, you can Google it. It's a hidden message inside there from Satoshi himself. And I also added a link so you can check it later. The link to the blockchain.com explorer, so you can check out the Genesis block, how it looks. And another special block is an orphan block. We will also talk about this later, but just that you know, it's a block that was not added to the main chain, to the main blockchain, but it was a valid one. So why don't we add it then? The issue here is because we have a lot of miners doing this on the same time to find blocks and so on, and sometimes it happens that they are doing this simultaneously. So at the same time they find a valid block, and now only one will win, so we can only add one to the blockchain and the other one will be invalid. That's the orphan block then, and it will be decided by who gets the next block on top of each other first and so on. So this is not always easily, and it doesn't also not happen that often. I think once a week or something. And I add also a link to Blockchain Explorer as well for orphan blocks. They also have a page where you can check out all the orphan blocks that happened in the last time. So thanks for this. This was a quicker video about the blocks, so you understand what a block is, and then we can go into more details about transactions and so on. So see you soon.